Welcome to Temple Builders Carpentry. Temple Builders. We problem solvers. Temple Builder Safety First. Okay, today Temple Builders, we talking about the electrical power circuit, okay? Now, when you hear circuit, you should think about circle. Now look down here, this is my power generator right here. This is my power plant. Okay, look at the smokestacks right here coming up. You see all the smoke, okay? Now right here is where the generators are at, okay? So what you're doing right here is coal is being trucked or either trained to this location, okay? And the coal, in the coal is where there's chemical energy. So you gotta burn the coal, okay? You'll burn the coal in maybe a furnace or what's called a boiler, okay? Which is going to boil the water and also that's gonna produce steam, okay? Now the steam is gonna turn the turbines, which is something like a fan, a big fan, okay? Now your coal went from chemical energy, okay, to thermal energy with the fire, okay? Now you moved on to mechanical energy dealing with the turbines, okay, and the shaft and the generator, okay? So that's mechanical energy now. So, all right, so in the generator, you got copper coils, okay, that's in a magnetic field, okay? Usually three-phase. You have three-phase generators, okay, which basically means that these copper coils are offset 120 degrees, okay? But we're gonna continue on. So this what these generators is what produce your three-phase electricity, and they run on. You usually see 3 cables, 3 to 4 cables. The 4th cable will be your ground or your neutral, and then you have the 3-phase running on these tall towers right here, which is known as pylons, okay? So once the electricity is produced in the power plant, okay, it comes out of the power plant and goes directly to these transformers, okay, which steps up the voltage, okay, to basically go over remote distances, okay. So you're gonna have the transformer to step up your voltage, because usually power plants be located far away from the area, the town, the city that is going to energize or that is going to bring the electricity to, okay? So you're gonna need to step up your voltage to go these long distances. And you look right here, you got your pylons, or what's called your transmission lines, okay? So your electricity leaves your power plant, gets stepped up by your transformers, okay? Now it's able to go the distance along your transmission lines till it get close to another town. Then it hits a substation, right? Hits this substation right here before here, and then it steps down. It's gonna step down so it can run on your distribution lines, okay? This what you normally see right here, which is your utility pole, okay? The utility pole right here, then you got a transformer right there. You're used to seeing this stuff, right? Okay, and so once it stepped down, okay, now it can go into your house at 120 volts, okay? So usually you're dealing with 3 voltages. You see this? I got A, B, and C. This called your service drop right here. Call your service drop because it's coming from your utility pole and it's finna distribute into your residence, right? You got your service drop with an ABC wire, and you got your weather head right here that's protecting your cables, okay? So what you got here is, once it goes into your home, you're dealing with single phase, okay? Single phase is what's powering your home, okay? So single phase is 120 positive. That's one phase, okay? Look at my sine wave. This called a sine wave. So sine wave starts at the top right here, then it flows down to the trough, and then it comes up to the peak. Okay, that's one cycle. Now look at this. This the other 120 I got. This 120 negative. But on this sine wave, it starts at the bottom or the trough and comes up to the peak, then comes back down. Okay, that's one cycle. Okay. Now usually dealing with alternating current, 120. Also we got right here, when these two are put together, they create 240 volts, okay? Now 240 is what is gonna pump or gonna bring juice to your major appliances, like your hot water heater, your electric range, your stove and stuff like that, your washer and dryers and things like that. And this 120 usually gonna run to your smaller appliances, okay? So yeah, so you got this 120 positive, you got a 120 negative, and both of these together create your 240, okay? And these usually dealing with AC current, you're dealing with 60, 20, you're dealing with 60 hertz is a common unit of measurement, 60 hertz, 50 and 60 hertz, right? And what that means is for every cycle, right, you got 60 cycles or 50 cycles in a second, right? Back to your sine wave. Okay, you're gonna get familiar with this symbol right here, the V. The V stands for volts, okay? We can compare electricity to water. So your volts is your pressure, right? So if we had a water hose right here, so when you turn the water hose on, you know, the water has pressure to it, okay? And that's similar to electricity. Now, we're talking about electricity on a basic level. Now, I don't want no electrical engineers to get mad at me, or no journeyman electricians to get mad at me for explaining this. Okay, but I'm talking about it on a basic level, okay? Yeah, you can compare it to water. Yeah, water that's coming out of your pipe, okay? And voltage is your pressure, okay? Another unit of measurement with electricity is this A right here, is amps, okay? The amps is gonna be your intensity of current, okay? So the best way I can see that, or my way of describing that, I would say if you was along the river bank, okay, on the edge of a river, okay, when the water passed that point that you standing at, okay, that volume of water or that current passing that point, the volume of water could be considered like the amps, okay? And another, that's a way that I look at it, okay? But another unit of measurement dealing with electricity is ohms, okay? Ohms is your resistance, okay? So how I see the resistance is, let's talk about that water that's flowing in that river, okay? There's rocks in the river, there's fish. So all these things is contributing to the resistance or the flow of the river. You see what I'm saying? You got the river banks, and too, that the water is running along. That should contribute to the resistance or have friction towards the water. Okay, you got debris in the water. Okay, so same thing with electricity in the conductors, right? The electrons, when they flow, they're bumping into other atoms. They're bumping into electrons. So it got resistance, and also the load is gonna have resistance. But let me continue. Okay, so when you starting right here at your drop service, okay, this your transformer that's outside your house, your utility pole. So you got your drop service with A, B, and C line. Okay, so A is gonna be your hot, B gonna be a hot, and C is gonna be your neutral. Okay, so the way you make 3 voltages would be put A with C, okay, that's 120 volt. You can put B with C, okay, which is basically a hot and a neutral, and that's 120 volts. But then you can also put A, B, and C together, which would be 2 hots and a neutral, and that will create your 240. Now let's look right here. So once your cable's going your weatherhead, it comes down your conduit right here. Comes down your conduit, your cable is in your conduit, you get to your meter. Okay, usually you can have a main meter that'll be located outside, and you can have a sub panel, or excuse me, this is your meter. This is your electrical panel. You have a main panel that's gonna be outside, okay? Then you're gonna have your sub panel that'll be inside, okay, usually. Okay, a common thing, okay? Now you look at this circuit right here, and look here, this my hot black going up here, okay? You got it powering right here, my switch and my light. You got the red right here going this direction. I got a receptacle right here with my toaster, okay? Now this middle wire, this my neutral, okay? So in order for electricity to flow, right, you gotta have a complete circuit. Okay, so right here, this is 120. I got my hot with my neutral right here. I'm delivering 120. But as you continue on, look right here, as the hot wire goes on right here, and this hot wire keep on. It hits right here. Look at this. You got the hot right here coming into this receptacle, and you got the neutral hitting it. Okay, so now you got the 240. That's where your 240 is for your stove. Okay, I'm just giving you a little basic overview of what you're looking at, okay? So normally with amps in your circuit, you're gonna have 15 to 20 amps for small appliances, right? Small appliances. And then you're gonna have 20, 40, 50, 60 volt, 60 amp breakers, okay? In your electrical panel. You can have for your major appliances, you can have 20, 40, 50 or 60 volt breakers in your electrical panel, okay? So let me see, I believe I went over everything. Yeah, this dealing with your electrical power circuit and your single phase 120 alternating current that gets distributed to your residence, okay? It'll be it can be different for commercial and industrial voltages, okay? All right, if you like it, if you like the content, hit the like button, subscribe, leave a comment, okay? Become my apprentice, Temple Build.